Hello, so this is a continuation of the series of videos that I've been doing. So for those of you who this is your first time of seeing this video, I have done some videos on the general GRE test. So the series of videos I'm going to be doing is going to be on the advanced GRE. So you can stay tuned. Alright, let's go and answer the questions we have here. So what the question says what is the sum of all integers such that x lies between negative 37 and 35. So you're told to sum all integers between negative 37 and 35. And then what you'd observe here is, here there is no equality sign here, while here there is an equality sign here. So what this means is, when you're going to add, or when you're going to list all the integers between negative 37 and 35, you should not include negative 37, but here x can include 35. So to begin explaining this, let me just give you an overview of what we mean by an integer. So generally, whenever you hear the word integer is just another name for whole numbers. So for some of you might not be very used to the term integers and then rational numbers and the likes. So anytime you hear the word integers is just a mathematical term for whole numbers. And then, like, an example of whole numbers which we shall be calling integers is, so examples of integers now. So the examples of integers, like we said, they are whole numbers. So an example is 1, you could have 2, so you could even have negative whole numbers and then negative this. So these are examples of whole numbers. But then whenever you have a number like 3 divided by 4, now this is not a whole number. That is, this is not an integer. So you know what we're talking about. Alright, now to answer the question, we want to sum all the integers between negative 37 and 35, excluding negative 37. So the first thing I'm going to do is I'm going to list all the integers between negative 37 and 35. So we're given is negative 37 less than x less than or equal to 35. Now to list all the integers, since we're told that negative 37 is less than x, so that means I'm going to have to start from negative 36, sorry. Then we go to negative 35, negative 34, negative 33, and then you wouldn't want to begin to list all the numbers. So we're going to represent that with ellipses. So we keep on going to 0, 1, 2, and then we keep on going that way until we end at 34. And then since we said 35 is inclusive because of the equality sign here, so we are going to include 35. So what the question says is we should sum all the integers between negative 37 and 35. Now your first attempt might be to begin to add all the numbers, negative 36, negative 35, and then begin to add all of them. Now the thing is that the danger here is, number one, you might make mistake. Then number two is sometimes the list of integers that you want to sum might be very, very large. So, and then you have a limited amount of time to answer all these questions. So the best thing is, which is the fastest way or probably an efficient way of trying to sum these numbers? Now what you'd observe here is the difference between negative 36 and negative 35. The difference is 1. The difference between negative 35 and negative 34, the difference is 1. Between negative 34 and negative 33, the difference is 1. And then when you keep on going, the difference here is 1, the difference here is 1. So the difference here is 1. Now anytime you observe a sequence like this that have a common difference, then you would say that the sequence progresses arithmetically. In other words, this is an example of an arithmetic progression. So let me write that down. An arithmetic progression. So it's an example of an arithmetic progression. So now we already know that what we want to do is we want to find the sum of n terms, some particular number of terms of an arithmetic progression. Now how do we do that? Now, so you would have to recall, since we're going to be proving this, so all I'm giving here is just tips. So we're not going to prove this formula that I'm going to write down, but what we know is the sum of the n terms of an arithmetic progression is given by n all over 2 into 2a plus n negative 1 times d. So you already know this, right, from your undergraduate. You already know this. And then this is the same thing as n divided by 2 into the first term plus the last term. So I'm going to explain what this means. So what we have here is, so the n here is the number of terms, so the a here is the first term of the arithmetic progression, while the d here is the common difference. Now looking at the question we have, so we observe that they have a common difference, and the common difference here is 1. So the common difference is 1. Also, what you'd observe here is this is the first term of the arithmetic progression. So our a here is 1. Now the last one that you want to find is, what is the number of terms that we have here? Good. Now here is a little sensitive, so you have to be very, very careful when you're trying to sum this. So from 1 to 35, so from here to here, so we have 35 numbers here. Then from negative 36 to negative, so there is negative 1 here. From negative 36 to negative 1, from here to here, you have 36 numbers. And then also when you include 1, so this is going to be plus 1. So the total number of terms we have here is going to be, the total number of terms, that is our n, is going to be 36 plus 35 plus 1. And then when we sum this up, this is going to give us 72. So now we know the number of terms, we know the common difference, and then we know the first term. So let's now find the sum of the 72 terms. So we want to find S72. That's what we want to find. We want to find S72. So that is so let me draw this down. So we want to find S72. Now S72, according to the formula we have here, it says the number of terms, which is 72, divided by 2, multiplied by the first term. The first term we have here is 1, so that is 1, plus the last term. Now the last term we have here is 35. So that's the last term we have here. Sorry, the first term we have here is, so this is not 1. I'm very sorry for this. This should be negative 36. So the first term we have here should be negative 36 plus the last term. Now the last term you have here is 35, so that is 35. So this is what we have here. So I'm sorry for that. So what we have here is 72 divided by 2 times, now negative 36 plus 35, that's going to give you negative 1. And when you multiply this together, you have negative 36. So this is the solution when you add up all the numbers, and then that implies that the solution of this problem is going to be negative 36. Now also, what you'd observe is, I wrote down two formulas here. So you could either use this formula here, or you could use this formula here. You will still arrive at the same result. Now to use this formula here, all you need to do is you substitute your a here with negative 36, and then the common difference with 1, and then you still observe that you obtain the same answer, and that completes the problem. Thanks for watching.